Life on Earth depends on many nonmetals. For example, carbon, nitrogen, phosphorus, and hydrogen and oxygen are all nonmetal elements found in your body's DNA. A model of DNA is shown in Figure 1. While many compounds are made with non-metal metals are essential to life, and some nonmetals are poisonous and highly reactive, still other nonmetals compared to metals, nonmetals have a much wider variety of properties. However, nonmetals do not have several properties in common. Physical properties. A nonmetal is an element that lacks most of the properties of a metal except for hydrogen. The nonmetals are found on the right side of the periodic table. In general, most of the nonmetals are poor conductors of electricity and heat. Solid nonmetals tend to be dull and brittle. If you were to hit most of the nonmetals with a hammer, they would break or crumble into powder. Also, nonmetals usually have a lower density than other metals. Many nonmetals are gases at room temperature. The air you breathe contains mostly nitrogen and oxygen. Some nonmetals, such as carbon and sulfur and iodine, are solids at room temperature, but bromine is the only nonmetal that is a liquid at room temperature. DNA is made up of atoms of nonmetals and it is essential to life. Chemical properties. Atoms of nonmetals usually gain or share electrons when they react with other atoms. When nonmetals and metals react, electrons move from metal atoms to nonmetal atoms. For example, when sodium and chlorine react, they form table salt, NaCl. An electron moves from the sodium atom to the chlorine atom. Many nonmetals can form compounds with other nonmetals. These types of compounds, the atoms share their electrons to form bonds. When two or more atoms bond in this way, they form a molecule. A water H2O molecule consists of two hydrogen atoms and one oxygen atom. What are the families containing nonmetals? Look back at the periodic table. There are nonmetals in group 1 and groups 14 to 18. The families containing nonmetals include carbon family, nitrogen family, oxygen family, and halogen family, the noble gases in hydrogen. The carbon family in 14. Only carbon is the nonmetal. Carbon is especially important in the role of chemistry of life. Proteins, DNA, fats all contain carbon. Most of the fuels that are burned to yield energy contain carbon. Coal contains large amounts of carbon. Gasoline is made from crude oil and a mixture of carbon compounds with one carbon atom to chains of several hundred carbon atoms. A diamond, which is shown in Figure 2, is made of pure carbon. Nitrogen family. Group 15 nitrogen family contains two nonmetals, nitrogen and phosphorus. Nitrogen makes up about 78% of the Earth's atmosphere by volume. In nature, nitrogen exists as two nitrogen atoms bonded together to form a diatomic molecule, N2. A diatomic molecule is made of two atoms and is the form of nitrogen is not very reactive. Although living things need nitrogen, most of them are unable to use nitrogen from the air. However, certain kinds of bacteria can use nitrogen to form from the air to form compounds. This process is called nitrogen fixation. Plants can then take these nitrogen compounds formed by bacteria in soil. Farmers also add nitrogen compounds to soil in the form of fertilizers. Lightning in the Figure 3 also converts nitrogen into the atmosphere into the form that can be used by plants. Phosphorus is the other nonmetal in the nitrogen family. Much more reactive than nitrogen, phosphorus is in nature and is always found in compounds. Lightning. The energy released in the atmosphere in the form of lightning is able to break the bonds between nitrogen atoms, causing them to react with oxygen. Plants are able to use the nitrogen in this form. The oxygen family, group 16. The oxygen family contains three nonmetals: oxygen, sulfur, and selenium. Oxygen is a gas at room temperature, whereas sulfur and selenium are both solids. You are using oxygen right now. With every breath, oxygen travels into your lungs. There it is absorbed into your bloodstream, which distributes all over your body. Like nitrogen, oxygen, O2, is a diatomic molecule. Oxygen is relatively reactive, so it can combine with almost every other element. If you've ever smelled the odor of rotten egg, then you already are familiar with the smell of some sulfur compounds. Sulfur is used in the manufacturing of rubber. For rubber bands and automobile tires are like the ones shown in figure 4. Halogen family. Group 17 contains nonmetals: fluorine, chlorine, bromine, and iodine. These elements are known as halogens, which means salt forming. Their properties of acetine, At, are unknown because they're extremely rare. All the halogens are very reactive. Fluorine is the most reactive of all the elements. It is so reactive that it will react with almost every known substance, including water. Chlorine gas is extremely dangerous, but is used in small amounts to kill bacteria in water. Although halogen elements are dangerous, many of the compounds of the halogens form are quite useful. Compounds of fluorine make up non-stick coating on cookware. Fluorine compounds can also be found in toothpaste, which is shown in figure 5, because they help prevent tooth decay. Noble gases, the element group 18 is known as the noble gases. Do not ordinarily form compounds because atoms of noble gases are not usually gain, lose, or share electrons. As a result, the noble gases usually are non-reactive. Even so, scientists are able to synthesize some noble gas compounds in the laboratory. You have probably seen a floating balloon filled with helium, Hg. Noble gases are used in glowing electrical lights such as the one shown in figure 6. Hydrogen is alone in the upper left corner of the periodic table is hydrogen, the element with the simplest atoms. The chemical properties of hydrogen are very different from those of the other elements, so it cannot be grouped with the family. Hydrogen makes up more than 90% of the atoms in the universe. Stars, like the Sun, are shown in figure 7, contain massive amounts of hydrogen, but hydrogen only makes up 1% of the mass of the Earth's crust, oceans, and atmosphere. Hydrogen is rarely found on Earth as a pure element. Most of the hydrogen is combined with oxygen to form or is in water. Neon lights. Glowing electrical lights are often called neon lights, even though they are usually filled with other noble gases or a mixture of them. The lights above show the elements for helium, nitrogen, argon, krypton, and xenon. Now, I have not highlighted anything in the metalloids group, so you're going to have to find this, but I will read it to you. Metalloids: between the metals and nonmetals of the periodic table lie in the metalloids. The metalloids have some properties of metals and some properties of nonmetals. All metalloids are solid at room temperature. The metalloids are brittle, hard, and somewhat reactive. Most common metalloids are silicon, Si, ordinary sand, which is mostly silicon dioxide, SO2, the main SiO2 are the main compounds of glass. The compound of boron, B, and oxygen are added during the process of glass making to make the heat resistant glass. Metalloids are the most useful property is the ability to conduct electric current. The conductivity of the metalloids can depend on the temperature, exposure to light, and the presence of impurities. For this reason, metalloids such as silicon and germanium are used to make semiconductors. Semiconductors are substances that can conduct electric current and some under the conditions not under other conditions. Semiconductors are useful to make computers, chips, transistors, and lasers. Semiconductors are also used in solar cells, such as the one in Figure 8. The solar cells in the International Space Station transform energy from the sun into electrical energy. Some solar cells contain silicon, which is a semiconductor.